Hello, this is Mrs. Huntley. This is Module 1B, Scientific Notation, and this is Lesson 7. You should be on page 43 of your supplemental packet, and this is what it looks like. When I talk about page 43, I mean this number right here. I know you're not actually on the 43rd page, but that number right there. We have to add an EQ at the top because there's no space for it, and the EQ is what is scientific notation. So I know it says class activity, and we actually are going to be doing a class activity tomorrow in class, but I want you to take some notes ahead of time. So think about the following situation, or following question. Why do you text? Why do we, send out a really quick text, and when we text, do we always type everything out, or are there some shortcuts that we take? So most of us would agree that texting is a fast and efficient way of communicating. In fact, texting allows us to abbreviate many common phrases, LOL, that type of thing. Mathematics and scientists also have a way of expressing really large and really small numbers in a fast and efficient way, and it's called scientific notation. Just like texting allows you to communicate quickly, scientific notation is a special way of writing a number that would otherwise be tedious to write if it were left in standard form. Now right here, I want you to draw your attention to the word standard form. Standard form is sometimes also called decimal notation or decimal form. Okay? And when they talk about tedious, they mean like really big numbers that are going to have a lot of zeros, those kind of numbers that they get so big that we don't even know how to say them out loud. That's when it's nice to use scientific notation. And there's a number of different reasons that we use scientific notation. So scientific notation, what is it? It's a shorthand way of writing very large or very small numbers. Now these four expressions that are in this box here, they are all, believe it or not, representing the exact same quantity. So let's take a look at, if I were to write them all in standard notation, what they're going to look like. So this first one, 500,000 times 10 to the negative 1 power. Now that negative 1 is telling me that I'm moving my decimal 1 to the left. I'm creating a smaller number with it, okay? So if I do that, the number that's written here is actually 50,000. Okay? The next one, 5/10 times 10 to the 5th power. This, again, this decimal tells me, or I'm sorry, the exponent tells me how many times I'm moving the decimal. So I'm just going to come over here where I have more space. So I've got 0.5, and I need to move my decimal 5 times. So here's 1 time, 2, 3, 4, 5. Now in each of those little valleys, I need to add a 0. So when I've done that, I see that 5/10 times 10 to the 5th power is also 50,000. Okay? 5 times 10 to the 4th power, again, I'm going to show you again because I want you to see multiple times what I'm doing. So with the number 5, my decimal's right here, right? And this is telling me I need to move it 4 places. So I'm going to go 1, there's times 10 to the 1st power, times 10 to the 2nd power, times 10 to the 3rd power, times 10 to the 4th power. Now my decimal's here, and in each of those valleys, I'm going to add a 0, and again, I've got the number 50,000. This isn't a surprise because I told you that they were all representing the same number. Now I've got 5,000 times 10. Here's my 5,000. Again, here's my decimal, and I'm just multiplying it times 10 one time. So I'm just moving it once, add in a 0, and again, I've got my 50,000. And you're probably thinking, well, which one is the shorthand? And I'm going to tell you right now, out of all of these representations of scientific notation, all of these representations of a power or a number being multiplied by a power of 10, this one right here is the only one that is in scientific notation. We have some rules about how to write things in scientific notation. So there's only 2. The rules for writing a number in scientific notation, the coefficient, this number that's out in front here, has got to be a number that's greater than 1 and less than 10. So like this one here, this coefficient is less than 1. So that one is not in scientific notation, even though it looks very similar because I'm multiplying it by a power of 10. It's not truly scientific notation unless this number that's out in front is greater than 1 and less than 10. Obviously, these two other ones, that number that's out in front, that coefficient, is significantly larger than 10. So those are not in scientific notation. Now, it doesn't mean that they're wrong per se. They're still representing the amount of 50,000, but they're not in scientific notation. Why do we want something in scientific notation? Why would that be important? Well, we have to standardize how we look at scientific notation so that we can compare quantities and quickly be able to tell which one's larger, which one's smaller. And if we have all different kinds of coefficients out here, it kind of takes away the efficiency of using scientific notation. So that's one of the reasons. Okay, so some rules for what I was doing. So when I was converting things into decimal notation or standard notation, to convert a number from scientific notation into standard or decimal form, the power of 10 tells you how many times to move the decimal. If the power of 10 is positive, you are making the number larger. If the power of 10 is negative, you're making the number smaller. So if you remember up here where it was a -1, you know what, I just used the number that was here and I moved my decimal to the left. So I was making 500,000 into 50,000. I was making or creating a smaller number when I was making that conversion. Whereas with each of the other examples, I was moving my decimal to the right and I was making it a larger number. So again, positive makes it a big number, negative makes it small. I used to tell my students that if it was negative, you're moving your decimal to the left, and if it's positive, you're moving your decimal to the right. Trying to remember right and left and up and down and all that other stuff, I have found makes things a little bit difficult. So if you just remember positive makes the number bigger, negative makes that number smaller. Hopefully that will help you remember which way to go. So down below, they're giving us two expressions, and they're saying which of the expressions is greater. First of all, let's take a look. Our number, our lead coefficient here, is greater than 1 and less than 10, and I'm multiplying by a power of 10, so this is scientific notation. The second one also, the 3 is greater than 1. It's less than 10, so I know this is also in scientific notation. And they're saying which of the expressions given below is a greater number, a larger number. Now we've got negative exponents. Remember, the greater the negative, the smaller the number. So although your first instinct might have been to go with this top one being the greater number because this number is larger, because this is significantly more negative, the -5 is more negative than the -2, this is actually a much smaller number up here. Let's go ahead and put it into standard form. So I've got 6. My decimal is here, and it's multiplied by a power of 10 to the -5th. So I know I'm going to be moving I'm going to be creating a smaller number. So I'm going to move it 1, 2, 3, 4, 5 times. My decimal ends up there. 1, 2, 3, 4. So this first number in standard form is a decimal and then 4 zeros and then the 6. 3 times 10 to the -2nd. Again, write your 3. Your decimal is currently here. I need to move it. I need to create a smaller number by a power of 2. So there's 1. There's 2. So the second number is 0.03. And you know that this is a larger number. Okay. Now it's not asking us to say how many times greater, so I don't need to do a division or anything. It's just asking us to order these. Let's go on to the next page. Okay. Oops. This is something we're going to do in class tomorrow. There we go. Okay. The next page. I know it says homework, scientific notation part 1, and that would generally be what we do in class, but I actually want you to do this with me on the video And I'm going to show you a couple of things, and then you're going to complete this before you come to class tomorrow. So the table below includes numbers written in standard form or scientific notation. Change the numbers written in scientific notation into standard form and vice versa. Use a calculator if needed. Now, I will switch over to the overhead and show you where different things are on the calculator, but I'm having some issues with some sound in the recording. So I'm hoping that this is going to work. I need you to bear with me if I run into some problems with the sound, but I'm going to switch to the overhead really quick and see if I can show you on a calculator where this key is. So this is, if I'm typing this into the calculator, this is 10 to the 0 power, and I want to be able to make sure that you know how to use your calculators. So bear with me. Okay, so this is the Texas Instruments 30X2S. This is the calculator that we asked you to get for 8th grade. And the on-off button obviously is down here. Let's clear out. The button that we're going to be using to raise something to an exponent is right here. Sometimes it's called the caret button. So this first example is 10 to the 0 power. So if I were to type in 10 raised to the 0 power, I'd put in 10, then the caret raised to the 0 power, and hit enter. And it should give me 1, because we know anything raised to the 0 power is 1. So the caret button, that's how you raise something to an exponent. All right, so we are back to the packet, and hopefully the sound is working, and I won't know that for a few minutes, so you know before I do. Okay, so if I type in my calculator 10 to the 0 power, exponent notation would be 10 to the 0 power. Standard form, meaning what does 10 to the 0 power look like? It's a 1. So 10 to the first power, exponent notation would be 10 to the first power. What does it look like in standard form? Is just 10. 10 to the second power, 100. 10 to the third power, I'm sorry, 10 caret 3 is how you would type it into your calculator. Exponent notation would be 10 to the third power. And what does that look like in standard form? It would be 1,000. The next one, of course, would be 10 to the fourth power. And that looks like 10,000. So to the right, this is just multiplying 2 times 10 to the 0 power. So exponent notation, how would I show that? And what is that going to look like in standard form? I'm sorry, I wrote a 2 there because I can't think about a number and write a different number. So that would be 10 to the 0 power. So 2 times 10 to the 0 power, we know 10 to the 0 power is 1. 2 times 1 is going to be just 2. What I'd like you to do right now is pause the video and fill in the rest of this table using the pattern that we have from the 10 to the 1 power and just calculating out the standard form. If you need to use your calculator, by all means use it. Okay, check your table against mine and make sure that you have the same answers. We're just following a pattern, and I just want you to get accustomed to following that pattern and understanding, you know, kind of what different powers of 10 look like. Okay, so for the next one, I would like you to first figure out what it's going to look like by what power of 10, and then multiply out that power of 10, just like we were doing on the other page. So if I've got 4 times 10 caret 3, that's going to be 4 times 10 to the third power. So my 4 is there. You can use your calculator, but I'd like you to get accustomed to it. My decimal starts here, and I'm multiplying it by 10 to the first power, 10 to the second power, 10 to the third power. Here's my decimal. Add in those zeros. So it'll be 4,000. Okay, I'm going to just erase this away so that my copy looks nice and neat for you. The next one, 6 times 10 to the fifth power, caret 5. So it's going to be 6 times 10 to the fifth power. Again, my 6 is here. Decimal starts there, moving it 5 times. 1, 2, 3, 4, 5, fill in with zeros, and that's going to be 600,000. I hope that this is making sense to you. If you're lost right now, you need to make sure that you're writing down some questions so that you remember to bring your questions into me tomorrow so that we can address them in class. Now I'm erasing away those things that I add in there because the decimal is very much over to the right now. It's no longer next to the 6. So why don't you pause the video and see if you can do 7 times 10 to caret 8, filling in the other 2 blanks, and then come back and check your work. I lost my train of thought as I was doing that one. I apologize. I got distracted by something, and I forgot how many zeros I had already written down and how many I still needed. So that would be correct there. Now the next problem, I don't want you to get confused. This is 8.1 times 10 to the 3rd power. So write your 8.1. If you notice, the first time you're moving your decimal, you don't have to add a 0 in there. So there's 1 power of 10, 2 powers of 10, 3 powers of 10. So it'll be 8,100 is my correct answer there. Okay. Now this next one is kind of going backward. Well, you know that it's going to be 4 times 10 caret 9. So go ahead and see if you can fill out the table that's on the right-hand side here. Again, remembering that when you have something that doesn't have a 0 right next to it, that first move, you're not going to be filling anything in. So see if you can figure out that one and then come back and check your work. Okay, so this is what you should have. 4.2 times 10 caret 3 is, of course, to the 3rd power, or 10 to the 3rd power. 10 to the 6.9 times 10 caret 5 would be 6.9 times 10 to the 5th power. If you're multiplying those out, let me show you something else. Instead of hopping your decimal, like doing the zeros, what you could also do, and this is kind of what I was doing, and I want to make sure that you understand it first of all. Okay, so 4, okay, my decimal would come next, and I can write it down. That's fine. So it's 4.2. If I'm write down like 2 and I think that's 1 power of 10, 2 powers of 10, 3 powers of 10, then I'm there without doing those little loop-de-loo things on the bottom. If you like the loop-de-loo things, by all means, keep writing the loop-de-loo things. So 6, 1 power of 10, 2 powers of 10, 3 powers of 10, 4 powers of 10, 5 powers of 10. 7.12, 1 power of 10, 2 powers of 10, 3 powers of 10, 4, 5, 6, 7, 8. Now the difficulty comes in when you, like me, have trouble saying numbers and writing something else. That's when I tend to make mistakes. Okay, so what I would like you to do before class tomorrow is from the table above, write 2 things you've learned about scientific notation and complete the following sentences. In scientific notation, as the exponent power goes up by 1, the standard number's decimal is what? Are we moving it right? Are we moving it left? Are we creating a bigger number? Are we creating a smaller number? In scientific notation, as the exponent power goes down by 1, the standard number's decimal is what? Move to the left, creating a smaller number. What's happening? So try to answer those quick questions before you come to class tomorrow, and I will see you then. Have a good night.